Hello, we're back. Example 2. I'll move this over so it's all part of the same line. This is from the textbook. But I've changed the numbers, okay? So these numbers are different, all right? I think that because this kind of question is different from the ones you've encountered, it would make sense for me to go over some examples like this. The stopping distance for a boat in calm water is modeled by the function d of v equals this equation here, where d of v is in meters and v is in kilometers per hour. What is the stopping distance if the speed is 25 kilometers per hour? So we're still using the guess method. Okay, so what's been given? We've been given the equation d of v Okay, I've been told that d of v, the distance for stopping a boat in calm water, is modeled. So the stopping distance is that. So d of v is stopping distance. D of v is in meters, and v is kilometers per hour. So it's kilometers per hour, it has to be in speed. I'll see if your textbook has that, because that's speed. So I'm going to maybe put a star there. Okay. What else do we need to know? Okay, so if d of v and v are unfamiliar to us, it would make sense to go back and say, well, where is our x and our y? We know that a variable squared is only responsible for x being squared, so it has to represent x. We also know as well that d at v is function notation, where function notation represents the y. Okay, so y is equal to 0.004 x squared plus 0.2 x plus 6. So we know that v and v squared is x. D of v is function notation representing y. Okay, so u, the unknown, what are they asking us to find? So what is the stopping distance? So u, unknown. So find the stopping distance. So what is that? We know that stopping distance is the y value. Okay? If the speed is, or equal to, let's put equal to because it makes it more mathematical, 25 kilometers per hour. Okay, so we know that speed is x. Okay, so we are given x. We're wanting to know y. Well, y on its own side is exactly an equation like this. So e, the equation, to find, put the e as the equation. Okay, so equation to find y, okay, to find y, we can use y equals ax squared plus bx plus c, or we can use y equals a x minus h squared plus k, or we can use y equals a x minus r x minus s. Okay? All right, s is the solution. So the solution, take the e, the u, and the g, all these. So we're going to use the standard form, which is here. So we're going to use y equals ax squared plus bx plus c, because that's one of the ones that we were given an option for. But this one is the same as, let's use that, y equals 0.004 x squared plus 0.2x plus 6. What else do we need to know? We need to know what y is, but we know the speed is 25 kilometers per hour. So y is equal to 0.004. X squared is 25 squared plus 0.2 times 25 plus 6. We're going to follow BEDMAS. Okay, so exponents are what we do first. 25 squared. If we don't know it, type it in. 625. So 0.004 times 625. This multiplication is on its own, so we can do that. 0.2 times 25 is equal to 5 plus 6. Multiply these out. 0.004 times 625. Y is equal to 2.5 plus 5 plus 6. So we add the 5 and the 6 to that. Y is equal to 13.5. Okay? So our S, the last S, is our sentence. Referring back to what the unknown was, find the stopping distance. So therefore, the boat stops in 13.5 meters when it's traveling, when it is first traveling, when it first is traveling at a speed of 25 kilometers per hour. So the speed of your vehicle will determine how quickly or how slowly you will be able to stop. So that's the stopping distance, okay? All right, what is the initial speed of the boat if it takes 8.7 meters to stop? G, what's been given? U, what's the unknown? E, what's the equation? S, what's the solution? Last S is what is the sentence. Okay. So given. We're still given this info. If we want, we can write the original equation. But again, if we want, we can rewrite it using X and Y. So we're recopying. Just make sure that you don't do it too fast or you'll make a mistake. So D of E is the stopping distance. So that's in meters. So we've established this. We've established this already, right? So that information determined what was given, but this information comes before A and B. So this information also appears in this B section, or this section for B, right? And then speed is kilometers per hour. All right, what's unknown? So what is the initial speed of the boat? So what is the initial speed of the boat? Okay, so it's the starting note. I think that initial is somewhat misleading because it makes us think about what the y-intercept is, but they're really saying before it begins to stop or slow down. Okay, so initial speed, initial meaning speed before it begins to apply the brakes, right? Okay, so what's the speed? Well, V is the speed value or a variable. So we want to know what the V is. What do we need? We says it takes 8.7 meters to stop. So when it takes 8.7 meters to stop. So taking 8.7 meters to stop is the stopping distance. Okay, so that's when you have a distance to stop, that's stopping distance. So stopping distance represents y. Okay, so we know that y is 8.7 meters. Equation. Well, what kind of things do we need? Well, we need to find v, which in our case, so v we know is x, right? If we know that they're the same, that's really important. So to find v, it's the same as saying to find x. Well, to find x, therefore use the standard form and quadratic formula. I think it's good that we did questions like this, because this will clarify what you need to do in your homework. Okay, so solution. We're going to take what's in the equation, the unknown, and the given. So we're going to use the y equals 0.004 x squared plus 0.2 x plus 6, and we're going to sub in anything that we've got. So we want the initial speed, which is v, otherwise known as x, okay? And then it takes the 8.7 meters, which is the y. So we're going to sub in the 8.7 for y, rewrite the rest of our formula, and then move the 8.7 to the other side. So 0 equals 0.004 x squared plus 0.2 x plus 6 minus 8.7. So 0.004 x squared plus 0.2 x, and then 6 minus 8.7, negative 2.7. Okay. So we are at the start of the standard form. So standard form there. Okay, so we're going to sub in the values of 0.004, b equals 0.2, and c equals negative 2.7. I'm going to sub that into x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. So x is equal to negative b, where b is 0.2, plus or minus square root of b squared, which is 0.2 squared, minus 4 times a, which is 0.004, times c, which is negative 2.7, and 2 times a is 0.004. Okay, x is equal to negative 0.2 plus or minus 0.2 squared, 0.04, and then remember all of this is being multiplied, so you're multiplying here and here. So you go 4, that's negative, times 0.004 times 2.7, which is also negative, to give you plus 0.0432, all divided by 2 times 0.004, 0.008. Okay, x is equal to negative 0.2 plus or minus, so we have 0.04 plus 0.0432. So 0.0832, all divided by 0.008. So we've got to move this over. Okay, so x is equal to negative 0.2 plus the square root of this number, 0.28844 dot dot dot, all divided by 0.008, and then we're going to subtract, so it's negative 0.2 minus the square root of this number, 0 decimal. 0.2884 dot dot dot, all divided by 0.008. Okay, so you're adding the square root of this number and you're subtracting the square root of this number. Okay, so you got to add these. So you got that number already on your screen. So you're going to add a 0.2, which is negative. X is equal to 0.08844 blah 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 divided by 0.008. Now when you're dividing by a number that's smaller than 1, then the numerator is going to become much larger than expected. So divided by 0.008. 11, x is equal to 11.055 blah blah blah. Now there's no mention of rounding, so let's round to the nearest first decimal. So x is equal to approximately 11.1, and x is the initial speed of the boat. I think so. So that is kilometers per hour. Okay, and then this one, this is going to be 0.2, which is negative, minus 0.28844 is x equals negative 0.48844 divided by 0.008. Now, I'm going to stop for a second. So I know that this is a quadratic, and I know that some values don't make sense because our values can't go anything less than x equals 0, right? Because negative x values don't make sense in this context. The reason I know that is that this is speed of a boat. So when I get this question, it's going to give me a negative x value where the speed cannot continue to be negative, right? So this number, I'll finish it, 0.008 gives me a negative speed, which is not logical, 61.055. So speed can't be negative. Be negative. Okay, so therefore, this answer is inadmissible. In other words, it's not entered into evidence, right? It's not included in that, okay? So does this make sense? I think so, but we'll talk about why. So therefore, the initial speed of the boat is 11.1 kilometers per hour. Okay, when it takes 8.7 meters to stop. So does that make any sense? Well, if I draw an XY axis, and I know that the value for the y-intercept is c, okay, and it's positive, so it's smiling, means that this value is here and it goes up. I know that I can't have any negative values here, so that's not included. So because x is the speed of the boat, okay, so that's where the y is the stopping distance. So if it's 6 here, right, then it comes down, and then when the x value is 11.1 kilometers per hour, that speed is a little bit higher. Make sure that it matches the so what was the number? 8.7. 8.7, right there. Got to make it fit on the graph, okay? Okay, so when it's 8.7, it's 11.1 kilometers per hour. Oops. So there's 6, the y-intercept, it opens up. 8.7 is the stopping distance, and it has a speed of the boat of 11.1.